5 different types of mining. We'll probably not get to the end of that today. So then on Monday, I'll introduce 3 different types of processing. How to separate the ore into the trash and the valuable stuff. So we're going to do 5 types of mining, 3 types of processing. And in the process of doing that, we will hopefully answer this one, which I think might have been a separate study goal. In assignment 9.1, the difference between surface and subsurface mines. Oh, that was at the end of 16, yeah. So all this chunk. General stuff about mining, you've heard some of this before. This applies to all mining. All mining. All mining is number 1, a big habitat disruption. All mining affects habitat for something. And you know, because mining has a really big footprint, it has a really, really massive impact on habitat quality. But it's scaled. So like if you can't afford it, it's stuff. Yeah. And you live there, and it's like a beautiful place. Number 2, you got a lot of stuff left over after you make your holes in the ground. That would be the crumbs in your cookie lab on Wednesday. The spoils and tailings are, if I'm not mistaken, the dirt in the way, so that's the crumbs. And then when you refine the ore, you've got some like little crumbs left over after that. I can't remember which one is spoils and which one is tailings. I think spoils is the stuff that you take out of the ground to reach the goods. That's the big chunks of cookie. And tailings are like the little flecks of flour that you chipped off of the cookie chocolate chip to make it cleaner. So tailings are left over after refinement. Spoils are left over after excavation. Like when a gopher digs a hole, that pile of dirt, that's spoils. Bullet number 3 has come up 1 bazillion times. This might be the last time I say it, but I'm guessing it'll sound familiar by now. Lots of elements will bond with oxygen. But if that's really old crust, a lot of metamorphic processes release the oxygen. Meaning, the stuff that's been underground has been in geologic prison. It is looking to meet up with oxygen. So when you let it out of geologic prison, it's going to do its thing. A lot of elements that bond with oxygen when they rise to the surface will oxidize. They are able to bond, but haven't been able to because they were underground. So almost anything you dig up will oxidize. Almost all metals anyway. That's why the water that pours off a mine is often the dirtiest thing about a mine. The spoils and the tailings will oxidize at the surface, and then you can't keep the water off, so when that water pours down, it is now acidic water. That's bad for groundwater and bad for surface water. So new vocab term, you have to contain that nasty water. That's called impoundment. Right there. Impoundment is the containment of contaminated water. Usually you build like a temporary dam. And there's a general trend in mining. It's really hard to to make money 1 person per cookie. But now the question is there an economy of scale like Walmart and Amazon? Small mom and pops are disappearing because you have to be really big to make money. That's also true in mining. Instead of 1 person with 2 tools, it's now bigger tools, more people, smash the cookie really fast. So the scale of mining is staggering compared to the historic types of mining you probably imagined from before. I'll show you some pictures today that hopefully will surprise you a little bit. We've already talked about placer deposits or placer deposits before.
Yep.
Water slows down, so all the heavy stuff settles. I'd like to visualize that for a minute before I do the next slide. Imagine that the water is moving really, really fast, so everything is being carried. Boulders, school buses, your mom, everything is being carried. Water, really heavy stuff is getting pushed by that water. When the water slows down a little bit, which items will settle first? The what? The heaviest. We think density at this point, but I think that's not true. I think that the heaviest items would settle first. So you might get a rock this big, but I'll bet you if you had a 1 pound lead ball that had the same mass, that would all settle at about the same water flow. Those are called placer deposits. Places where the water slowing drops everything by mass. I think aside from differentials and drag, they would both go. So there might be a little density bias because of surface area contact with water. Right, but buoyancy, displacement. What do you think? The way that this is defined in the content that I see to teach this is that water movement settles things based on mass, which is why it's possible to go back and later sort them by density, because sizes that are the same will have a different mass, and that's how gold mining works. You find all the gravel of the same size, you pan it until you accelerate all the low density stuff, and the thing in the center is the gold. You can imagine a lead weight next to a rock of the same size, the lead weight's going to weigh more, so you'll be able to accelerate the rock out of the way and keep, so that's, they're mixed because they settled by mass, then you sort by size to determine which is the density. So placer mining or placer mining is to look through those placer or placer deposits. Now that all the heavy stuff settled, let's sort through the heavy stuff to find the gold, which is the most valuable, the densest. I've got a few different things to tell you about placer or placer mining.
Is that where Placerville comes from?
Yes. First of all, I wanted to remind you, and you may want to write this down because I'm pretty sure it's right. You can put a question mark if you want to double check me. That placer deposits or placer deposits are places where slowing water drops everything of a specific mass. Water at different speeds can move things of a different weight. So when the water slows down, everything of a certain mass settles at once. Those are placer deposits. Moving water sorts things based on their weight or on their mass. And placer mining is to look through those deposits for stuff that's valuable. This is especially true for gold. I'm almost exclusively talking about gold here. Your notes have to say that placer mining or placer, can we just agree on how to say this?
Placer.
Placer? Fine. That placer mining happens near water, like stream beds, river beds, or places that used to be a riverbed. Even if the river dried up, the deposit will still be there. Since placer deposits are made by water, if you find a gravel bed at the bottom of a cliff band on a river, that's a pretty good bed. That's a placer deposit. Interesting detail, as our planet heats up, all that permafrost is melting. So places where you had a river a gajillion years ago, river moved, there's a placer deposit, but that's been frozen for the last, 17,000 years or whatever. Canada, I believe, is the world's largest gold exporter today. Because all the permafrost, all the tundra is melting, now we can go scraping through a lot of those ancient riverbeds. I should also point out, and I'll tell you this story later, that placer mining is like the gateway drug for deforestation in the tropics. I'll come back to that. These bros are digging through the side of a stream, place where the water was going fast, and then it slowed down. Pretty good bet that where the water changed angle, you're going to have some placer deposits. They put everything in that trough, which has bars of a different size. So all the bigger stuff stops at the tall bar, and then the medium stuff stops at the medium bar or whatever. I think it goes the other way around. Little bar to trap all the little stuff, medium bar to trap all the middle stuff, large bar to trap all the large stuff. Then they take stuff out of that bar, and remember, it all had the same mass, so now that it's sorted by size, you can swirl out the rocks and the really dense stuff will stay in the pan. That's how gold mining works. Now you sort it by density to find the stuff with a higher density. First by mass, then by density. Back in the day, this is how we got all of our gold. And today, small-scale backyard hobby placer mining might look like this. But most placer mining is large scale today. Like I told you, it's all Walmart and Amazon model, like this. Or like this one. Notice that the river's been diverted into a canal, and that entire section of the river is a work spot. In the tundra, where you used to have rivers, thank the Lord for global warming, now we can go dig through that. And again, tricks of sorting by size and then sorting by density. But I gotta talk about the tropics. How many of you have heard some sort of shocking number about tropical deforestation, like 7 football fields per second, or like some like square miles per day, or like 7 Texas per year, whatever the number. I know that they're always really shocking, but I never remember them. There's a really interesting detail about that tropical deforestation. I've been waiting until this part of the year to clarify. In unit number 4, I mentioned this for about 5 minutes. I don't know how much experience you all have with tropical rainforest. I have very little myself. But there's one thing that I can't stress enough. The tropical rainforest is really, really, really scary. Like, humans are not well equipped for tropical rainforest. You might know that Joseph Conrad's book was titled Heart of Darkness, because obviously like the Central African Congo rainforest was seen as like a really dangerous, scary place to go. You may have heard that like a lot of native tribes in the Amazon basin have an average life expectancy of late 20s, early mid 30s. Like an old man in the Amazon is like, whoa, you made it to 50, bro. That's pretty amazing. You must have like serious skills. Because you know, tropical rainforest is it's scary. It's burly. There's like sharp, dangerous, toxic plants and amphibians, and like there's the catfish that swims up your urethra. I'm sure you've all heard about that one. Whenever I swim in water, it's like a reflex. I have to pee. And when I went to the Amazon, I'd always remember halfway through. I'd be swimming to like, oh. And then I'd be like, why am I supposed to remember something? What am I supposed to remember? Like, can't think, peeing feels too good. And then like right when it's too late, I'd be like, oh right, catfish, God! Never had a problem. Pretty rare that they go into a human, but it happens. There's like pit vipers, jaguars. Trees fall over, it's easy to get lost. Everything gets all slippery when it rains, and it rains a lot. Super hot, so you're always sweating all those bugs and like the flies that lay the maggot that eats the meat. I was in Belize and I saw the remains of a cougar, jaguar, like mountain lion sort of looking thing, that had died of botfly larvae. Like you've seen like really severe acne, like it looked like it had just over its whole body, just like all these big like botfly cysts. Like that's not a good place to go. Did I ever tell you a story about a tarantula?
Yeah.
I've had some bad luck in the tropics. Humans are pretty fragile. That's not an easy environment. So here's the reason that I mentioned that. If you represent 1,000 square miles of Amazon headwaters, there might be a few valuable hardwoods out there, but they're not very common. There's so much tree density and tree diversity that I'd have to cut down a bunch of useless crap. It's not even useful as firewood for the most part. I'd have to cut down a whole bunch of useless crap to find one rare hardwood that I can sell to make a fancy desk. And maybe you've heard that a lot of our commodity grains are grown in the tropics, you know, because it rains a lot. But again, cutting down all this forest, that's a lot of dangerous, sketchy work. To grow soy at like $1.20 per bushel or whatever, that just doesn't quite pay off. That's just too gnarly. Like if it's on the edge of the city, sure, we can expand urban areas. But to cut down new forest, like to penetrate into the deep jungle, that's not worth it. You know what is worth it? Going back there to look for placer deposits, because you know there's a lot of water in the tropics. That's why it's a rain forest. So with all those gazillions of square miles of rivers, you've got a ton of water. With all that water, you got a lot of placer deposits. So now this is actually what starts deforestation. It's like a process. The one thing that's valuable enough to go back there is gold. I guess a few precious stones as well. I read a really shocking statistic when I was shopping for wedding rings for my wife and me. In the United States, 1/2 of the gold market comes from illicit mining. Think about that market value. Like that's a lot of dollars. 1/2 of US gold is not from official, legal, government-sanctioned mining. So here's how it works. I run a gold syndicate. Probably a legitimate business on one side and like an illegitimate business on the other side. I've got a couple of goons that I have well equipped and well paid. They've got chainsaws, they've got big rifles, they've got land-to-air munitions so they can shoot down spotter planes. They've got like heavy machinery where they need it, chainsaws and flamethrowers and stuff. And I say, hey guys, here's some GPS coordinates. Some scout said that they think there might be some gold over in that one deposit on this one river. You guys, good luck. And these scouts will cut road, get all the way back there. Shocking detail about this correlation. This is the heart of the human slave labor industry, is illegal mining. You may have heard that there's like a thriving human slave trade today. And the part that gets all the deadlines, all the headlines, of course, is the sexual exploitation of humans, which is totally horrific and tragic, and I'm trying to diminish that. But for the human slave trade for labor, like actual work slaves, today those are almost all in illegal mining. Disposable workforce, you don't have to feed them too well. If they like starve to death or get eaten by the pit vipers, you just find some more powerless poor people and put them to work too. Send my goons back there. Good luck, bros. Go get me some gold. They do whatever they got to do. Please look up. Tremendous impact. Because this is illegal, the whole point's to do it fast and cheap. So the water pollution is really severe, and this is one of the primary sources of methyl mercury in water, the really scary type of mercury, the type that your body will absorb. I'll talk more about that when we do processing on Monday, but this is one of the primary sources of water mercury on Earth. And once they're done with the logging camp and they move, with the mining camp and they move out, like now it's worth it. There's a road, there's a flat spot, I can see the edges, I'm not afraid of the jaguars and the snakes. Now it's worth it to walk in where it's a little more comfortable and safe and cut down that one tree, steal those parrots for the pet trade, maybe slash and burn to grow some soy, and when the soy stops growing, we bring in the cattle to eat anything else that'll sprout. Tropical deforestation is definitely not for the lumber, and it's definitely started by illegal mining. Almost everywhere that there are tropics, this is the primary deforestation. The penetration to virgin forest is almost always for mining. Next, in number 16, number 2, is underground mining. This is the type that you saw in Zoolander, which I'm sure every student, of course, has seen. Classic of American cinema. Underground mining is, like the tunnels with like the helmet, with like the headlamp and like the pickaxes, the carts. Please look up, it's the red thing. On here, it's the red. Where you make like a little tunnel, find your valuables, bring them back out of the tunnel. Coal mining in England during the early Industrial Revolution was all like this. You've probably heard about tunnels collapsing in Chile where people were looking for diamonds or something. And this tends to be a pretty small impact. Let's try to answer that warm-up, which is the second half of number 16. Please look up here. If I wanted to get that green spot, I've got two options. Reach it from the surface by moving all the dirt out of the way, or go underground, subsurface, and move just a little dirt out of the way. It's a trade-off. Pros and cons, watch this. Less pollution, more expensive, more danger. More pollution, but cheaper and safer. Yeah?
Can you do that one more time?
Less pollution, more expensive, more danger. A lot more pollution, but less expensive and less dangerous. Like, look at the water pollution. If it rains here, all you need is an umbrella to cover up the hole and a tarp to cover the dirt. But if it rains here, you've got a giant rain funnel and a giant pile of dirt. So you're going to have way more water pollution on the blue option. Imagine the amount of sediment pollution in the blue option. Imagine how much runoff you'd get from the blue option. But walking stuff back and forth through that tunnel, that's going to cost a lot of money, and tunnels are sketchy. They collapse all the time. Please look up. You probably imagine something like this. Like when you talk about mining, the average American visualizes this. You know, like you crawl on your hands and knees through some sketchy tunnels with like little wood things on top, little headers. And you try to like not shake things because it'll all fall down around you. Indiana Jones. Maybe you're lucky enough to have a donkey to take away the carts full of stuff. But globally, there's almost no one working at this scale these days. Like today, that's a really small shovel. And like the cheapest donkey is about that size. And the tunnels nowadays are usually quite massive and they're really carefully engineered. And there's like all sorts of fascinating technology about how they pull this off. With like the movement of the water and like the airflow and like the material, it's all one-way streets, you know, so all this stuff is going one way, all this stuff is going the other way. And talking to people who design these mines, it is really, really amazing. It's like an intellectual challenge that I think most of you would find really engaging. Remember, super expensive, super dangerous. But less surface pollution, less water pollution, less habitat impact. You know, you could sneak one of these under the library. If there was like gold buried under the library, you can do this in like urban areas. Because all you have is that one little point of surface impact. Anything about that one? Third type is called open pit. This is the blue option. The blue option. So it's simpler and it's safer, so it's more profitable. These are going to be some big impacts. Yeah, bro.
So when you said that like the one on the right has more pollution and more expensive, were you referring to open pit or surface mining?
Open pit is a type of surface mining. Because you never have to go underground. You can still see the sunlight. This is just like it sounds, man. It's just a big hole. Like, really, your notes could just say big hole. If you're copying this whole slide, you probably wrote too much. I really want to show you this picture. That's a big hole.
Whoa.
Like, our brains can't really make this work. Do you know that your brains can only visualize very small numbers? Like, if I say visualize 1 soccer ball, I know you did, and if I say visualize 2, I know you could, and if I said visualize 4, most of you could, and almost all of you made 2 by 2. And if I say visualize 10 soccer balls, it's very, very rare that you actually have a visual image of 10 soccer balls, but it's possible. There's only a very, very small percentage of humans who can truly visualize 100 soccer balls. Your brain starts to use tricks, like approximations. Our brains aren't made to handle large numbers. There are many languages that didn't have words for big numbers, because you just don't need anything bigger than a few. Our brains aren't really scaled for large things. So when I try to show you this, your brain starts looking for a way to put this in perspective. Like, if you really had to estimate and go through a rational process of telling me how big that is, you'd be like, well, I see that there's a road going down, so I guess that road would probably be kind of like that hole that they're putting the thing in, or maybe like that one hillside where I've seen a road. First of all, this is all spoils and tailings. You can see all that flat surface. Remember I told you the scale of runoff impacts? Imagine how many gallons of acidified runoff will enter this watershed when that snow melts. Even if it's just subtle acidification, as the water evaporates and the acids stay in the water, that's going to be at some point a pretty significant concentration of acids. Imagine how much that would accelerate the leaching of naturally occurring ingredients in that watershed. Imagine how much dust is going to blow away when this is all summer and that stuff's all dry, or how much sediment pollution will go to the wetland at the bottom of this watershed or whatever. It's really significant. But let's look at that road. See it? With like the Tonka truck driving down? Right in the middle is like a little tiny yellow Tonka truck. Y'all see that? It's kind of hard to see. It's like a little mining truck. So if you look at this picture, for example, your brain sees the road. And let's do this really quick. Looking from here, you can see that there's a truck. And you can see that there's some tires. And like here's a berm, so you're looking from a road. Down, and there's a few other bits of equipment. And you can see the shadow of a truck driving up, and there's the tires. And your brain just made an effort to scale this to a size that visualizes in your brain somehow. What's funny is you're probably thinking about the wrong tires. Because if you see the tires on the side of the road, the thing in the background is a Toyota Tacoma. So that road is, yeah, a 2-lane road for this thing, but like a 6-lane or 8-lane road for the Tacoma. When you look at that road, you were scaling this to some frame of reference that you interpreted as the most likely and rational. It's normal, we all do that. But when you look at that tire, you've never seen a tire that big. I know that none of you has seen one of these trucks unless you were in one of these mines. Because they had to build the trucks in the mines. Because they're really big trucks. So homeboy goes up the staircase to the control center on the 3rd story of this truck. There's no like steering wheel. There's like computers and dials and like burners and levers. They have like a crew to drive it. So then like when you see those like scrapers, you realize like that's a really big scoop if it's filling up that truck in a single load. And like that's a really big road, so that's a really big hole in the ground. So holy crap, like there's the school bus that brings all the workers down in the morning. And then like that dozer is obviously way bigger than that school bus. So that road is obviously way bigger than I was thinking. So that hole's a lot bigger than you were thinking, and so's that one. I think it's 4 miles across. That's a pretty big distance. That's halfway to downtown Goleta.
Where is that? And what's the name of the mine?
I used to know. I want to say Utah. And it has a name that sounds like exactly like, it's like the gold mine, or like the copper deposit mine, or like it, whatever it is, it's like it's like named for, it's like the least imaginative name ever. It's like the Waffle House mine, like it's exactly what they do, like it's that thing. Big copper mine. Yeah.
Do they have heavier regulations for like runoff to lakes than they do like the ocean?
Yeah, I know that there have to be because the Clean Water Act affects all navigable waters.
So isn't that the Salt Lake, the Salt Lake in Utah?
If this were in the Salt Lake watershed, I don't know that it is. Utah's pretty big. Most water in Utah doesn't go to the Great Salt Lake, it goes to the Colorado River. There's numerous watersheds in Utah. Next, jeez, look at that. Look at all the impoundment dams. Do you see the impoundment dams in the background? Those big puddles of water in the back? That's what I'm saying about the water management. You just have to like control and retain as much water as possible. So you build all the piles so that the water all goes this way and then it all pours into a containment dam. Then you let that water evaporate mostly and you take all the concentrated stuff and you dispose of it. Look at that, like the phone poles and the train tracks in there, and you go, oh, trains, right? Like, oh, right, big hole, right? See why I focus on the big hole thing? Okay. Usually strip mining is a special type of open pit mining. Like, imagine mining a peanut butter and jelly sandwich for jelly. There's like a layer between other layers, so you just scrape off the top layer until you can collect all of the jelly layer. That's strip mining. It's like an open pit that moves sideways because you're just trying to take a strip of stuff. So instead of being like a single glob target, it would be a strip mine if that was just like a whole shelf of that. Usually it's not as deep. And strip mining is very common for coal because coal is a sedimentary deposit, so it's found in sediment layers, so it's like peanut butter and jelly, like flat shelves of coal. So with strip mining, you've got associations with coal, which means you've got associations with hydrocarbons, especially toxic stuff because of, you know, all the petroleum, oil, natural gas ingredients, volatile organic compounds, all that stuff. Please look up. It's like an open pit mine, but it moves sideways because it's layers, sediment. Like coal beds. Yeah, I wonder if that's why they're called beds. Because it's flat, like a bed. Blankets. Jose's deep thoughts. I'm gonna think about that until next year, I'll bet you. I got 12 months to answer this. Pretty sure I just answered. I'm going with it. That's all the critical thinking I need. And look, if you were going to say what type of mining is worst, you could definitely say that mountaintop removal is the worst. The scale of this is totally unbelievable. Please look up. There was a time back in the Industrial Revolution when you would find a couple of poor laborers and have them dig a tunnel and then cart out all of that coal. That was like early Industrial Revolution, underground mining, manual labor, disposable workforce, black lung, and so on. Today, some amount of coal is still removed in this manner, not a lot. Usually, when we do that type of underground mining, like I showed you earlier, it's machines and heavy machinery and like very carefully, but you know, okay, underground. There are some places where this happens close to the surface, so another way to get coal is strip mining. That was the main method, 70s, 80s, 90s. But what if we're looking for much bigger deposits, like landscape level? Where weathering across mountain ranges makes this layer of coal, this coal bed, contiguous for miles. Imagine if you're looking at the Riviera and there's just like a black line that you know has coal in it. Well, there was a time that people would just tunnel into it, underground mining. But machines are big enough and energy is cheap enough that instead of spending like a few years with a couple of hundred workers, you can just take all of that in a few days with just a couple of workers. And some really big machines. Watch. You anchor a cable and drive it all the way around to remove all the vegetation and topsoil. It's like a cheese wheel. Then, when all that stuff is down in here, you stick in dynamite and go. And the whole top of the mountain is now gravel and sand. And then you just start at the top and you just push it all over until you filled in down here, and you're left with a nice flat pile of coal in the middle of a flat parking lot. It's called MTR, Mountain Top Removal. Yeah?
Is this still considered underground mining? Is that considered?
All of these so far have been surface mines. The only underground is the tunnel. If you can see the sky, it's not underground. Yeah?
Do you know like the net energy profit? Like how much energy is used to get the coal that becomes...
I don't have a number for you, but I know that this is the most profitable mining in the history of mining. You've got almost no labor and very, very, very short operating times. Please look up. It's really difficult to find photographs. But that's what I mean. You can see the pile of coal just sitting there. Like this photograph really does, I think, a good job of matching my lecture. You can see that there used to be a ridge line that came down here. And so you just peel off the top, dump it in so you can see where this is all filled in now, and then scrape off that stuff. There was probably something similar, like this layer was probably continuous to this ridge line, so you can see where that material was also scraped in. My hunch is that this was a ridge line and this was another part of that same system. And this has already been removed, and that's next. You know, machines are really, really big, and labor is really, really expensive. So you just get a couple dudes that are really good with machinery, and then you just load the train cars. Remember when we talked about the train cars in the energy unit? How many train cars full of coal are burned every day or whatever? Gotta come from somewhere. Yeah.
I just thought this was interesting. I drove out to like a small town in Washington to visit college, and it was right along the Columbia River, right where there's a railroad track, and there was just like trains of coal going like the full drive. Yeah,
I'm not surprised. You can see that also when you drive to Las Vegas, if you take the shortcut to Barstow or around Barstow. And there's like a number of, I was in downtown Memphis, Tennessee, and like just like right through the middle of town, there was a train that probably lasted 10 minutes. It was like 2-3 miles of train cars. It was just all coal, like you said, coal, just like the basket ones. Well, this is where it comes from. They're places like this. You can just see like the little black stain of coal. And then that used to be complicated wilderness where the top scraped off just to make the parking lot so you can drive away the coal. In many ways, this is like the logical next idea, like makes totally good sense that this is how we would get our coal. But children, I challenge you to think about something. Please look up. What used to be down here? Like what carves the canyons in the mountains? Yeah, maybe. But even more basic than maybe that, there's 100% there was water down there. There was a president who said that the Clean Water Act wouldn't apply because now there is no more mappable waterways. That interpretation was generally rejected. But a few years ago, a little regulatory change made it profitable to do this across large swaths of the United States. Again, it is now pretty difficult to pull this off. It's not really economical anymore. But for that brief period, we launched like 7 or 8 years worth of mountaintop removal projects, and those are having a tremendous impact in Appalachia today. Really, really severe impacts on surface water and water pollution. By the way, those impound dams sometimes break. What do you all see downriver from that dam? Can you all see that little town up there? Right on the edge of the screen? So there's a lot of interesting debate about whose environmental quality was threatened by this activity, mountaintop removal for coal. Will you pause the